All right, so we're going to start out tonight with a conditional statement that's pretty similar to one that we started conditional statements with, so it shouldn't be too uncomfortable for you. The statement is, if a shape is a quadrilateral, so if a shape is a quadrilateral, then it has four sides. Okay, and this is, again, this is a conditional statement. So I'm going to kind of write out here to the side. Conditional. There's a conditional statement. Now, in our conditional statement, we can identify a hypothesis, P, and a conclusion, Q. And we can even say that P implies Q. And we can even do our Venn diagrams, right? We can have our big thing here for Q. That's our everything that has four sides. And our statement is saying that if a shape is a quadrilateral, so all the quadrilaterals we know of have to fit inside this four-sided shape world. So if something is a quadrilateral, then it also has four sides. And hopefully you'll recognize or you'll agree that that is a true conditional statement. So now we're going to come down here and I want to write the converse of this statement. So I'm going to say if, now remember I'm going to switch the hypothesis and the conclusion. So if a shape, and I don't want to say if it, because that's just bad grammar. If a shape has four sides, then, now remember that here comes the hypothesis, then it, because we've already identified that it is a shape, then it is a, you hear that banging? My wife just broke all my dishes. Oh well. Then it is a quadrilateral. And so we can look at how our converse has changed from the conditional statement that it was. So now our hypothesis and our conclusion have switched. We now will say that Q implies P. And if we wanted to draw a Venn diagram of this, we would now have the quadrilaterals is the big part, and the fact that it has four sides is the little part. Okay? But we want to think about this for a minute, because in the other example we did like this with Venn diagrams, when the conditional was true, the converse was false. But let's think carefully about this before we jump to that conclusion. A shape has four sides, so that means it's got to be inside of here. Is there any way that a shape could have four sides but not be a quadrilateral? Meaning, could you draw something, and you don't really need to draw on your paper, that has four sides, but it's not a quadrilateral? And the answer is no, you can't. So, again, I said you don't need to draw on your paper. So this is also a true statement. Remember I told you when we made our foldable, while you memorized hopefully that pattern of that conditional is true, converse and inverse false, contrapositive true, that's not always the case. That's just a visual I want you to have stuck in your head that you can spit it out anytime I ask you about it. Sometimes they're all true. And when the conditional and the converse are true, that's a very special case. And we can write something called a biconditional statement. And a biconditional statement is just when the conditional and the converse are true. Okay, and it's real simple to write. We write a shape is a quadrilateral if and only if it has four sides. Okay, so a biconditional statement is just a statement that is true both ways. So I could say, if a shape is a quadrilateral, then it has four sides. Or I could say, if a shape has four sides, then it's a quadrilateral. And we write that by putting the hypothesis and the conclusion, and we put if and only if in the middle. Okay, and all that says is that P implies Q, but also Q implies P. We write it like this. This means, I'm just going to write it all in the same color. P implies Q and Q implies P. So this is just a way of writing both of these together. And if the conditional and the converse are true, then the biconditional is true. So if the conditional statement and the converse statement are both true, then that tells us that the biconditional statement is true. If either one of these is false, the conditional or the converse, then the biconditional statement is false. So that is something you really want to remember, right? You might need to write it down. If the conditional and the converse are true, the biconditional is true. If either one of these is false, the entire biconditional statement is false. I don't know if y'all know what a spoiler alert is, but that's a spoiler alert. Write it down. So here's going to be a little example of what you're going to have to do with this. So I'm going to give you a biconditional statement. Let's say a polygon is a triangle if and only if. This is a math shorthand way of writing if and only if. If you do it in your English class, they're going to call it a typo. If you do it in your math class, this means if and only if. So a polygon is a triangle if and only if it has three sides. So here's a biconditional statement. You need to determine, is it true or false? Now, there's only one way to determine this, and if you try to get cute with it on the test and not show your work and not write it out, it's going to blow up in your face. The only way to determine if a biconditional statement is true or false is to write out the conditional statement, write out the converse, and see whether they are both true, which would make this true, or if one of them is false, it makes the whole thing false. So let's do that and write it out. Okay, here is our P. Here is our Q. So our conditional statement is going to be the one that says if P, then Q. Our converse is going to say if Q, then P. So conditional. If a polygon is a triangle, then it has 3 sides. Okay, now let's write out the converse. Everybody wants to skip steps. You always want to show how fast you can do things. Try writing everything out and see what it gets you. So if a polygon has 3 sides, then it is a triangle. So now we're going to take a look at our statement. So if a polygon is a triangle, and over here we have is a triangle. That's our P's. Our Q's are the part about the 3 sides. Alright. So, conditional statement. If a polygon is a triangle, well, hopefully you know that a polygon is a closed figure with all straight sides. So, if you have a closed figure with all straight sides, it's a triangle. That's very true, right? Then, it has 3 sides. Is that also true? So this is a true conditional. Now we come over here and we say a polygon, so a closed figure with all straight sides has 3 sides. Okay, that's true, that could happen, right? Then it's a triangle. Well, that's also true. So if our converse, our conditional and our converse are true, that means that our biconditional is true. Right? So don't take this lightly because it was easy problems. You really need to understand the true false stuff that's going on here. It's not as easy as it looks. So take your time with it and be ready to talk about it.